Okay, today we'll be talking about our product in supply chain. So in our company, within our AI stack, we are mostly focused on supply chain. This means that we have a product which I own as a product owner. That goal is to automate supply chain from purchase ordering of raw materials or from the suppliers all the way to forecasting the demand or forecasting sales all the way to end consumers. So the goal for today is also to see how we integrated GPT into this story. So agenda for today is to start first with introduction of our product, then go into overview of GPT and see two use cases that we used GPT within our product. And in the end, of course, it's your time to talk Q&A. So before we start, something we are really proud of, and that is that our implementation of our product in fashion industry in Slovenia has been selected as one of the finalists for Go Digital Award. So it's a really huge thing for us. We are really proud of it. So actually, one applause for this, for my team that did it. So really thank you, and really thank you my team for this. So what our product does, so let's put ourselves in shoes or one, for example, manufacturing company. So we're manufacturing something. Let's say we're manufacturing pens, for example. So to make pen, you need an ink and you need a shell of a pen. So the first thing you need to order from a supplier your raw materials, the ink and the shell. So after you do this, you get the raw materials on your warehouse. And the next step is to use those raw materials to schedule some building, how you're combining ink and how you're combining shell to build the pen. And you need to put those orders when you're producing something on which machine, what operation, and so on. And you end up with pens, your final products. And then you move those final products, those pens, into the stores according to what you expect to forecast in each store. And after some time, what happens is that there is different sales dynamic in each store, for example, like this. So, and you see some stores do have have less quantity after some time, while other stores have more. So while we still have something on central warehouse, you can still fill those stores with remaining parts. But if something happens and the stores get filled again on different sales dynamics, you also include another step where you're transferring the pens from store to store. So where the AI comes into this, when you even up everything, at one point it's, of course, demand forecasting. That's the step one where you can apply AI. Demand forecasting solves us the question of how much are we going to sell. Then you go into step two, which says how much do you need to order of raw materials to be able to produce what you're going to sell. Then you go into step three. Now you know how much do you need to produce, but when are you going to produce it? So where are you going to schedule the production of this item, on another item, and so on which machine, which operation, and so on and so forth. So this is optimization of production planning. And in the end comes in that you have to make transfers between stores at some point. If you're in the retail industry, you have different stores, different sales dynamics, and something is sold better in one store, something is sold better in another store, and you need to optimize transfers between stores. So this is kind of a high-level review of the models that our product possesses. And now let's add GPT to this. Why GPT? Because let's say that honestly hype is huge. And one thing about us is that we are lucky because we are Microsoft partners, so we have easy access to the OpenAI subscription in Azure. So introduction to what is GPT, I'm going to skip this because we're on data science conference, we should know this, and we should know how GPT works, make prompts, GPT, and so on. So we're going to skip this. So what are the challenges here? The first challenge is that you have some limited data, some generic knowledge, because it's cut off in 2021. So you need to get your own data, fit to your own data, make vector databases, and get your own data to be fitted to the model. Then the next issue is hallucinations, but if you're really smart, you can make really good prompt engineering, put constraints on the model, and get as best as you can responses. Then the security and privacy issue, which for us, and as I said, we are the lucky ones that have easy access as a partners to Microsoft OpenAI, which are, in our case, solved by this part. And the last issue is legal issue, which we, to be honest, we don't have because we are not applying large language model in such a way. So the core applications that we see as a potential for our product, or for our implementations, first is internal assistant chatbot. We see like 2 points of it. One point, you can make a customer support. So you get customer inquiries, you analyze those inquiries with GPT, and in the end, you can create drafts for answers. You can see what services the customer needs and so on. Or, for example, email automation, your user gets an email and you can automatically analyze the email, summarize the email, and create some drafts for possible responses. The other application that we kind of see is media monitoring, so monitoring articles, press clippings, and so on to see kind of sentiment of a vendor and so on, supplier in supply chain, to see maybe if there is something problematic with the supplier, maybe supplier is currently out of stock on some items, or there is some delays in shipments and so on from media articles. And third point is pure customer analytics. You can analyze the data from your customers. You have questions, Q&A, surveys that you can analyze with large language models. And these are kind of basis for implementation of enhanced AI services. So now I want to move into actual use cases. First use case came for us directly from our company, our internal company, because what happened, our HR department said that they have kind of spending a lot of time answering some queries, because a new employee comes to our company and then he asks, how do I apply for sick leave? How do I apply for vacation? And so on. And then, answering. So they wanted that automatized. I mean, our internal HR department. So we built one web app in Azure, which allows the user to directly communicate with our internal documents. And you can see this on examples. For example, what if I want to refer someone? For example, what if, like here, Martin decides to come back to BE-terna and I want to refer him? How I can do that? And I can easily ask the user interface directly in the app, and I can get the answer what I need to apply, where, and how. And even more, I get the document which actually shows where this is placed. And I can even get more information, for example, where exactly in this document this states, or I can even see what in our vector database, in what chunks does this refer to. So this is one first example, but let's be honest, we were talking about supply chain product. This doesn't come as a stack in supply chain product. This was just the first step to see for us if we can do something more into our product. And this is where the supply chain monitor comes in. This is the big thing that we implemented within our demand forecasting and supply chaining product. So let's recap what we said. We are making demand forecasting, we are monitoring inventory, we are making purchase order recommendations, and then we are approving them and scheduling. This is really, really high level. And let's, to this story, add GPT. So first, we have some data sources. Some data sources such as, you can name them like supplier communication, some shipment APIs, supplier databases, logistic data, social media articles, and so on. Some external data that you can use, and then use large language model like GPT to summarize those data. And we summarize those data, you can see some supplier issues. You can see product shortages, maybe shipment delays, and in the end, viable alternatives. And using that data, those insights that you get from GPT, you can use it directly into the system to make better purchase order recommendations with those additional info, those enriched data you get. And then again, data returns back. And then you can also apply GPT in another part. This is that you create a direct user interface with the end user. This means that you can notify the end user that maybe this item currently is out of stock at the customer side, or this customer has issues with this customer has shortages, this supplier has delays, and so on, and you can directly notify via email or via notification the planner or the purchaser about that. And the purchaser can then manually, if he needs, even change some orders or select another supplier for the item. So after we said where we are applying into our architecture GPT, how does this actually enhance our product? So from the 3 points. First, since there are disruptions in supply chain, you have much better adaptability to this. If, as I said, supplier doesn't have item on stock, you kind of have much easier way to adapt to that. The next thing is that you are really making an easy explanations to a end user why it is happening, and in the end, our end users are usually planners, purchasers, category managers, and so on, who are not technically very really people. So by creating a simple user interface where you can directly, in natural language, communicate with the system, it's much easier for them to understand why some recommendations are the way they are. And now let's see how this works. So on the right side, you see the interface of chatbot, and on the left-hand side, you see some data in BI application. So for example, the first thing user can ask, who are you, like what your chatbot is, and he answers what he does. You can answer questions about our product. He can answer questions about supply chain. He can answer questions about the data actually. So let's see this. Let's see this first. What if the user asks what are the sales in 2022 and what are the top items by sales in 2022? Then our chatbot can easily answer those 5 items, and you can actually see as a confirmation for that those were actual 5 items that he confirmed and the same sales as he calculated. So we kind of proved that it does the job what he should. But let's give him a bit more complicated issue, and this came from directly from something that our client wanted. We have a client in big pharma where they have issues that sometimes the ingredients are not available for them. So he can ask a question, what is the status of one drug? And the system replies, this drug had some temporary restrictions in 2022, in July, and so on. It can get some information about this directly, what's going on the market at the moment in the exact time, and get more information to make a better decision. And about implementation, since I said this is highly reliable on what our customer needs. So it's really customizable of what what implementation our customer has, depending on modules that we use. Do we talk about manufacturing company, or do we talk about just retail company? So it's really customizable, but it is customizable. So we can be customized whether you use Power BI or use Click or some other BI tool. It can be customized to use web interface standalone, or customizable to any data resources that you need. I said this was an example of using of big pharma data, like the data about market status of drugs, but it can be easily fitted to any other data you need. So conclusion, before I start the conclusion, I want to say that this way, we are kind of, from supply chain perspective, we are making supply chain definitely more resilient. That's the one point definitely about supply chain. The second thing is we are making supply chain much more transparent, which is kind of end goal of supply chain, to have it as more transparent as possible from the supplier all the way to the consumer, and you're making it more efficient. That's the main point. So to conclude, as I said, efficient. So you get a significant increase in productivity of a user. Then you improve your customer behavior modeling and profiling. After all, you improve, you enrich your data about your customers, and then you have much more improved reaction time because the end user, the user of the system, can quickly get information and make a much better decision more quicker. Of course, this is a natural language talking between the system and the user. And after all, this opened our door for much larger implementation of especially GPT large language module within our product and enrich the whole product as a whole. And this is what where I want to conclude, kind of to show the reward that we won. And feel free to scan QR code and see our offering of our product that I own. And that's it now. Now is the final point, your time to talk.
Do you have some questions? Yes, can you just wait for the microphone? One more here. Yeah?
Yeah, thank you for your presentation. I'm interested, you said that you were doing some basic data analysis. Is it possible to do some prediction with GPT?
We are not doing predictions here with GPT. We have our all big machine learning model about demand forecasting within it. But it could be possible, but we don't need it because we had it already, predictions made by our system.
But can you integrate that into that assistant somehow?
Predictions?
Yes.
Yes, they are integrated because they can ask questions about why do you predict that. Absolutely.
No, I was thinking, can you ask some questions to that interface, Gepetto?
No.
Can you ask him about predictions?
Yes, that's the point. You can ask, I didn't put that on slide, but you can ask why something predicted. I mean, like, why do you ordering this quantity? The user into the Gepetto can explain why the order happened. What was the reason for ordering? I don't know. I can say you ordered 5,000 because rounding was 5,000. You have packages of 5,000. That was the best order. Or you also can say we ordered 5,000 because in the next 2 weeks we are expecting to sell, I don't know, 4,000, and we need to keep 1,000 on safety stock. You can.
Thank you. Awesome.
Yeah.
Is it working?
Not sure.
Yeah.
Now it does. Again, thanks for the great presentation.
Thank you.
Very interesting. I have a question though regarding how you actually, the use cases of ChatGPT when you're modifying the recommended quantities which are output of predictive model, right? For demands forecasting. Does ChatGPT process both structured and unstructured data? And in what way, I mean, in terms of just high level, if he uses like emails to understand whether reliability of a supplier is on a certain level, can it really do that? And based on that, really modify the quantities?
I mean, it's not a problem for unstructured data. It's not a problem. So you can as sentiment, that's an unstructured data you get, like anything you get from the internet is unstructured data. So you get sentiment out of those unstructured data. But mostly it is based, the main part is based on structured data. What I said before, that's the structured data, the explanation about the recommendation, that's the structured data. But it's both.
So also he can use emails and like web articles.
You could.
To understand the reliability of a vendor.
You could.
Great.
You could.
Thanks.
We didn't do that part all the way too, but you could. That's a great idea, yeah.
Thanks.
Thank you for the question. Thank you for the idea.
Do you have more questions? Yes? Second, yeah.
Thank you for presentation. You said that this GPT model can be used to explain predictions, why item was predicted to purchase. Yeah. But how actually this explanation implemented? So it's like a RAG So you used your database data, retrieve some.
Our data, yes, our data, the data that's output of the system, our database data, so to say.
And maybe you can give some insights, like how this data is retrieved, retrieval mechanism.
What the last part?
Retrieval mechanism for RAG.
Didn't actually get the end.
GPT is just a generative model, so it's not in the context of your data. So you provide this as a context. But
yes.
How you retrieve it?
Retrieve it for our database, for our results, our database with results. We feed this to the system.
User give you an unstructured way of query, and how you transform this query to a query to the database.
It's prompt engineering. It's purely prompt engineering, how you're getting the query, which data to look for, which table to look for, and so on. It's pure prompt engineering from our side in the backend.
Okay, thank you.
Okay, thank you. We can talk so later. So.
Do you have some more questions? No?
That's all.
Thank you very much. It was beautiful. Thank you.